Hey guys, and welcome to another C++ tutorial. Today we're going to be doing something completely different. We're not actually going to be programming. Instead, we're going to learn about binary code. And the reason you need to know binary is because in the future it's really going to help us optimize our programs and conserve memory. And there's just going to be a lot of cases in C++ where knowing binary comes in handy. All of our variables are stored in binary code, and the actual representation of memory is all in binary. So we can do a lot of really cool tricks once we understand binary. And particularly knowing what binary is going to help you in the next episode when we go over advanced variable concepts, particularly memory size of the variables. So first, to get started, let's go back and look at the decimal system that we all know and love. So let's think of just a integer decimal number. How about 460? Now, when you see this number, you think 460. It's pretty obvious, but what exactly is this number? Let's try to arrive at the value of 460 in another way. Let's look at each digit individually. What are these digits actually, what's their value? So the first digit right here to the right, this is the least significant digit. This is the tens place, or the ones place, and in this case it's 0, so it has no value. This digit to the left is the tens place. It's 10 times more valuable than this. So even though there's a 6 here, we take that 6 and multiply it by 10 and get 60. So we add 60 to our total. Then if we go left one more digit, this is the most significant digit in this case. This is the third digit, and this is the 100s place. So in this case, we take 4 and then we multiply it by 10 and then we multiply it by 10 again to get 400. And then if we add those numbers together, then we're going to get 460. So let's do that. Let's take 4 times, and then it's going to be 10 times 10, which is 10 squared. Hopefully you know what the exponentials are. And then plus 6 times 10. And if you do the math on this, you're going to get the number 460. Now, the reason I'm showing you this incredibly simple thing that you probably already understand is because this is exactly what you do for binary. Binary is this easy to read. The only difference is instead of having a 10 here, we have a 2. That is the only difference. So let's write a binary number. Binary. So let's do the number 1010. So let's just take it one digit at a time. This is the ones place, okay, and it's a 0, so we ignore it. This is the twos place, and the reason we call it the twos place is because this is a base 2 system. It goes by powers of 2. Normally we would go 1, 10, 100, 1,000. In this case, we go by powers of 2, which is 1, 2, 4, 8, and it keeps going. So let's go ahead and take this digit. It's going to be 1 times, and then it's 2 to the power of 1, which is 2, plus, and then we want to do this digit right here, which is the other one. This is 3 digits from the rightmost digit, so it's going to be 1 times 2 to the power of 3, not 4, 3. So what this is going to get us is 1 times 2 is obviously 1. Oops. 1 times 2 is obviously 1. 2 to the power of 3 is 8, so 1 times 8 is 8. So 8 plus 2 is going to be 10. So this number 1010 is equal to 10 in decimal. It's that easy. If we added a 1 here, this would be the number 11. It's really easy to get the actual values just by doing that math, and you will get used to it, and you can actually learn to count in binary very easily. There's actually a pattern. Now, no doubt you've heard the term byte before. A byte is just 8 bits, and 1 bit is just 1 digit. A byte is pretty much the smallest value that can be stored in a variable. You can't store anything smaller than a byte in a variable. Now, you can still mess around with bits, but you can't have a variable that is smaller than a byte. Now, as you can see here, this is a byte. This is just 8 bits. Each bit is just a 0 or 1 value. You know that. We just converted from binary to integers, but I didn't tell you how to convert from integers to binary yet. Well, it's actually pretty easy to do that. Let's take the number 300 and convert it to a binary number. So the easiest way, at least I think, to do it is to use subtraction by powers of 2. Now what we do is we write out all the powers of 2 that are smaller than it, and we write them in reverse order. Now with a really big number, this will take a little longer, so it might be better to just use an online calculator, but we can do it with this small number so you know how to do it. So we're going to write the powers of 2 in reverse order, and you'll get really good at writing the powers of 2. It's pretty easy to remember them. we're going to write 1, and then 2, 4, 8, 16, 32, 64, 128, and then 256. Now these are all of the powers of 2 smaller than 300. 512 is bigger than 300, so we're not going to use that one. So all we do is subtract by the biggest power of 2 in this list. So in this case, it's going to be 256. So we're going to say 300 minus 256, and that's going to be equal to 44. Now, since we subtracted by 256, what we do is we put a 1 in its place, or we could put, a 1 on top if you're doing this on a piece of paper. So I'm going to put a 1 here, and now we have a new number to subtract. Our next number is 44. So now what we do is we go down the list and we replace all of the numbers that are bigger than 44 with a 0. So 128 is bigger than 44, so that's a 0. 64 is bigger, so that's a 0. 32 is not bigger. So since 32 is smaller, we're going to subtract by 32. So 44 minus 32 equals 12. So we're going to do the same thing. Since we subtracted by 32, we're going to put a 1 here. And we'll put 12 on the next line. Now, is 16 smaller than 12? No, so we're going to put a 0. Is 8 smaller than 12? Yes, so 12 minus 8 equals 4. We'll write 4 on the next line and replace the 8 with a 1 because we subtracted it. Now, is 4 smaller than 4? Actually, yes, it should be less than or equal to, not just less than. So we can subtract by 4, so we're going to subtract by 4. 4 minus 4 equals 0. So we're going to put a 1 here. Now is 2 less than or equal to 0? No, so we put a 0 there. Is 1 less than or equal to 0? No, we put a 0 there. So now we have our binary number 100101100, and this is 300 in binary. Wasn't that easy? Now you know how to read binary, you know how to convert from integers to binary and back again. The only thing you don't know how to do is to convert floating point numbers to binary, like 3.14159 or something. Converting this to binary is a lot harder. I'm not going to show you how to do it. If you're a mathy guy and you're interested in learning, just Google IEEE floating point conversion to decimal or something like that. Something like this. And that'll kind of show you how it works, but it's a lot more confusing, and honestly, I'm not concerned if you know this right now. As long as you understand what binary is and you can wow your friends with being able to write numbers in binary, that's all we need. So stay tuned. For the next tutorial, we're going to go over advanced variable concepts.